hyaline cartilage a minute ago. I think I was at 20x. You know, I always say that it has kind of this grainy nature to it. You know, it's because of the fibers that are in it, but it has just this, you know, appearance to it that you can tell when you first look at it. It doesn't look glassy. It doesn't look hyaline. It doesn't all look like an amorphous stuff. You can tell that there's texture to it. You see all these fine little lines and grains running through this, give it the classic appearance that it does, that's elastic cartilage. It's not hyaline because you can see all this elastic fibers and other things that are present inside of it. It still has chondrocytes sitting inside lacunae. It will have isogenous groups. When you look around, it's like, do you see many isogenous groups when you're looking around through this? I mean, you really don't. When you saw hyaline cartilage, it was loaded with isogenous groups. This doesn't have anywhere near the number of isogenous groups in it. Okay? There's all those fibers inside of it. So once you've looked, you know, almost get two computers or pull up two slides and just go back and forth between hyaline and elastic. And once you've done that a few times, it'll be very easy to tell the difference between hyaline and elastic cartilage. Okay?
What type of growth does it go? Does it go
You tell me.
Okay.
Why would you say that?
Okay.
Okay. Does it have isogenous groups?
Not that many.
Still it does that. Everything goes through interstitial growth. Not everything goes through appositional growth for cartilages. And for bone, what type of growth do we do? Do we do interstitial growth in bone?
Yeah. No. Only position.
You can't do interstitial growth in bone because the cells can't push apart their matrix. You're in a calcified matrix of hard bone. So when a cell divides, when it's trying to lay down matrix, it can't push apart bone. The cartilage is a spongy, gelatinous material, so you can actually push it apart, but you can't push apart bone, so you can't grow interstitially. It has a periosteum, so you can do appositional growth, but you can't do interstitial growth. Growing by increasing, like once you got an osteocyte sitting inside its lacuna, you can't make you can't divide and make an isogenous group inside of there. Or I guess you could, but you'd really squish the heck out of each cell if you did. I don't know if I've forgotten. Compact, or I do the bony things, okay? It's up top, isn't it? Okay. Well, there's a thing that almost looks like a Volkmann's canal. Okay. Whenever you can see where you have one osteon or Haversian system, you see you have another. This cut kind of cut through the middle part. So when you see this thing connecting, you know, instead of having just like a Haversian canal, like here and here, here's one canal, here's another canal, but then it interconnects between the two canals. So the structure that interconnects the two canals, two separate osteons or Haversian systems, is your Volkmann's canal. Okay? This would be a Haversian canal, this would be a Haversian canal, Volkmann's canal. Okay? So when you look around through here, obviously you see different osteons, Haversian systems, or whatever. Then you see all this stuff that you find in between. So this material through here would be what? Oh, you don't let me say it. What's it going to be? Is it lamellar in nature? Yeah. What types of lamellae do you have? You have concentric and you have interstitial lamellae or inter what?
Inter something.
Okay. Enter the Sandman, maybe.
Yes.
Okay. You need to know the difference between the inside and outside of the bone. So when you look at this, you see a smoothened outer surface and more of a kind of roughened in nature inner surface. It's also where you're going to find more of like where your blood vessels will be present, because that's where they're going to be coming into the bone. So when you magnify, you can be able to see that the material in here, I'll show you in a second, will be where your inner circumferential would be, and your outer circumferential lamellae would be out here. Okay, related to outside of the bone, inside of the bone. Everybody at this point knows when I look at these things, maybe I won't go that high, that the blackened structures here are your lacunae. What cell would reside inside of there would be an osteocyte. All the little fibers radiating out from it would be your canaliculi. What would you find inside the canaliculi? Philippodia, that sort of thing. So really on a practical, it's going to be about, is it a line going from here to here? Perversion system, osteon, a line from here to here, perversion canal, maybe one of these little circles, structure circled, a couple little arrows pointing at the canaliculi, and then just read the questions asking for the structure or asking what would reside within the structure. Okay? This is how you'd be looking at that. Type of bone, compact bone. Identify the tissue, compact bone. Okay, so if there was an arrow pointing, pick your spot, right here, pointing right here, and said identify the tissue. What would you say? Simple columnar. If there was an arrow right here, it said identify the tissue. If there was an arrow like right here, nothing to it, right? Any questions? Any other thing I didn't go over? Anything I need to go over? Anything you didn't understand?
Would you point to the brush border?
The brush border means I got to pull up a different slide. Yes, sir, I will. Brush border just basically means or represents the pattern that you see from the epithelia, because of the microvilli on their surface. So wow, you can almost see individual microvilli there. That's going to just blow my theory apart for you guys. Just ignore that you know. If you look over here, you definitely can't tell. I'm at 40x. You won't see. But anyway, you see this dark red line going across here. What really is something else. All this fuzzy stuff up here at the top of the epithelium is your brush border. Okay? This line right here is really what represents the terminal bar where we have our junctional complex. Everybody remembers what a junctional complex is, right? Those three, tight junction, intermediate junction, desmosome. That's what the dark line represents, because all these cells have junctional complexes attaching them together. Because you want to absorb into the cell, but you don't want stuff leaking back up between these cells. Now, also, one other place where you can see it identified as a brush border.
Well, we need to say simple columnar with the brush border.
No. Nice. I understand why you'd say that. No. When we were looking at these tubules, here, up here. Sorry, gotta move this a little bit. Those are different. Okay, so when we were looking at here, that simple columnar, simple. Oh, I know one other thing I need to do that I'll do real quick. So when we were looking at here, you may sometimes see all the stuff inside the lumen of these vessels called the brush border, because that's really what it is. It's all these little fuzzy microvilli and stuff. That's also brush border, but don't worry about it. That other slide I showed you did. Two things I just remembered about. Oh, okay, I